Hello and welcome. This is Chapter 5, Section 2 on Verifying Trig Identities, Part A. Our goal is to look at an identity and then prove that it's true. So an identity is just saying that this thing on the left is equal to this thing on the right, and these are going to be kind of made-up identities, but they are true. So we're going to walk through and use all of the skills that we learned using reciprocal, Pythagorean quotient, and algebra, and something called odd and even, which I don't think we're going to get into that till later, but those are our possibilities. So we're going to complete this proof by just telling us the rules, which we kind of did this already. I was writing those down. So the idea is, how did I get from this step up here, this step here, to this step here? So notice how this cosine squared changes into this. That's what's changing. So everything that's the same will stay the same, and then what is changing is what we're looking for. So how did cosine squared of x turn into 1 minus sine squared? Well, remember, cosine squared of x plus sine squared of x is equal to 1. And we can subtract sine squared to both sides, which is this Pythagorean identity. Pythagorean identity. All we're doing is just moving this to the other side and then substituting it in, which is a Pythagorean identity. Now, how did I go from here to this one? Well, what they're doing is they are actually going to multiply in or distribute those values in, which is just simple algebra. So once they use the Pythagorean identity, we're substituting that Pythagorean identity in here. We're going to distribute this to get this. And then we're going to combine those again, which is some more algebra. So 1 sine squared plus 4 sine squared is 5 sine squared of x. And then the minus 4. So again, we will do some more algebra to simplify that. We're just combining like terms in that case. So another example here is, again, we're just writing down the rule. Eventually we'll do all of them, so you're going to have to do this side and this side, but this is just a use of how the rules apply. So how do I get this is equal to 1? Well, cosecant squared of x minus 1, well, turns into cotangent squared. So that is a Pythagorean identity. Remember, the cotangent squared plus 1 is equal to cosecant, which is that Pythagorean identity. So we're substituting that in. So this is just your Pythagorean identity. Again, we have that cotangent squared of x plus 1 is in fact equal to cosecant squared of x. And if we just subtracted the 1 over, we get cosecant minus 1, and then we can substitute it in to get cotangent squared. Now, how do I get from here to here? Well, remember tangent and cotangent, we could write them as their quotients. So the quotient identities, remember that the tan of anything is equal to sine of that anything over the cosine of that anything. So you're just replacing that, but since it's a squared value for both, we have to put sine squared over cosine squared and cosine squared over sine squared. Now, the nice thing is those reduce each other. Those will kind of cancel out, but there's still something left, which is 1, which is just using that algebra skill of reducing. So see if you can try this one on your own. Pause it. I will have an answer shortly and walk through it as well. So as you can see, we had to distribute all of that out, and it simplifies to 1 minus cosine squared, which is just algebra. We just distributed it. We got that. Now this is actually sine squared, which is a Pythagorean identity. Then we flipped it upside down using reciprocals, and then we would use a Pythagorean identity again. Cosecant squared is 1 over cotangent, which is Pythagorean identity again. So let's actually walk through an example where we have to prove it ourselves. So we actually have to do the steps, and we have to write the rule. So we're going to be given this thing on the left, and we're going to have to try to get to what's on the right. So there are multiple ways you can do it. The first way is, I noticed they are both cosecant, and this is squared, so there's 2 of them, and this is cosecant to the 4th, so there's also 4 of them there. So what I can do is I can factor out one of these cosine squared of x's, or 2 of them actually, and what you're left with is cosecant squared of x, and then minus 1. It's like I'm dividing it out. So this divided by cosecant squared is this. This divided by cosecant squared is just negative 1. And all we did was factor it out, which is just algebra. Okay, now what we do know is we're trying to get to cotangent. So if we're trying to get the cotangent, the way to link cosecant and cotangent is using the identity that the cotangent squared of x plus 1 is in fact equal to your cosecant squared of x. That is one of our Pythagorean identities. So what we have to do is, well, in order to do that, we're just going to substitute that value in for both of your cosecants. So in this case, we will write that this is let's do it in a different color here. So we have cotangent squared of x, or 1 plus cotangent squared of x. You can write it in any order, and then we have cotangent squared of x plus 1, and then minus 1 here, which is, again, this Pythagorean identity here. So all I did was substitute this value in for here, and we substituted in for here. I just did it for both, and then we have this and this. And the nice thing is that if it's like this, those things go away or simplify. So using some algebra skills, we have the cotangent squared of x plus 1 times that cotangent squared of x, because those just go away, which is more algebra. Now our final step is just distributing that out, because we want cotangent squared and then cotangent to the fourth. So, and we can just rearrange it, write it in the order. So we just distribute this out here, so that times that is cotangent squared of x, and this times this is plus that cotangent to the fourth of x, which is more algebra. Now I could have combined these last two steps into one step. The more steps is okay, so when you do this, you'll press validate every step, so you can keep doing a lot of steps. So I could do this step to here, one of those, and then I could do this as a separate one, so I could do this twice, and then I could do a lot of things, more steps if I wanted to, but I like to simplify it and make it as condensed as possible. We could have just jumped to or got rid of this green one and done this black one and be done. So let's do example 4 here. We're going to try to get sine squared. So we know this, and we're trying to get sine squared. So there's a lot of ways we can try and do this. There's more than one way. So what I like to do is, well, we know that this is something, and we know that this is also something. We could write it. My biggest thing is like rewriting this as sines or cosines. Or we can use that Pythagorean identity right away. So let's just remember that the cosine squared of x plus the sine squared of x is 1. And then we know that the cosine squared of x is equal to 1 minus sine if I subtract sine to both sides. So we know that this is going to be cosine squared. So let's just do that right away. So this is just cosine squared of x. And then it's just times tangent squared of x, which is that Pythagorean identity. So now we can use a quotient identity. So we have cosine squared of x. Our quotient identity, just remember, this is sine squared of x over cosine squared of x, which is a quotient identity. And then we can just simplify those really easy using algebra, which gives me that sine squared of x. And then we're done. So let's do one last one before I have you try one on your own. We're trying to go from here to here. One thing I notice is 1 plus tangent squared is a Pythagorean identity. So we can just rewrite this as cotangent of x times, well, 1 plus tangent squared of x is in fact equal to your secant squared of x, which is that rule or Pythagorean identity. Now, what we can do, there's multiple things we can do. So we're going to first just change that to sine or cosine. So cotangent is cosine of x over sine of x, and that is still times by that secant squared of x. Let me rewrite the secant squared, and that is called the quotient identity. So let's move it up for some stuff. And then because this is all sine or cosine, I would like to change this to sine or cosine. The whole idea is these are not linked at all at the moment, but if I change them to cosines or sines, they will have cosines and sines in common. So this turns out to be cosine of x over sine of x times, well, secant is 1 over cosine of x. And we just take this square along, so this will be cosine squared. So we're going to move this to the denominator, or use that reciprocal identity to write it like that. Now there's a cosine on the numerator and 2 on the bottom, so we're just going to get rid of 1 on the bottom and the top one. So this ends up being 1 on the top, there's still a 1, over we have sine of x and cosine of x, which is just simplifying this using algebra, and that is actually what we're trying to get to, so we are done. I did lie. We have one last example before I have you try one here. So let's go ahead and try to take this and turn it into that. Notice that we have cotangent squared, cosecant of x minus 1 squared. So let's go ahead and look at this. This one is a new strategy I'm going to be using that you probably haven't seen for a while. Remember that the cotangent squared of x is equal to, or cotangent squared of x plus 1 is equal to your cosecant squared of x. So what I could do is rewrite cotangent squared of x as cosecant squared of x minus 1. So I'm going to rewrite that. So when I rewrite this, I have cosecant of x minus 1 all squared. And on the bottom, it's cosecant of x squared minus 1. Unfortunately, we can't just cancel these out. This is squaring the whole top, which is distributing it all out. This times itself. And this is squaring the bottom, or just the cosecant squared. So this, well, first let's write this is the Pythagorean identity, one of them. So now the key factor is that we have this, this is 1 squared. So if you forgot, we have a squared minus b squared. That's actually equal to a minus b and a plus b. So this is called the difference of squares, which is something you've been doing quite a bit, but you might have forgot. But this difference of squares is very useful, and we're going to use this strategy quite often. It'll be in your test for sure, so knowing that will be very helpful. So we're going to use algebra, the difference of squares, so let's just rewrite the numerator. That's not going to be changed, but the bottom, because this is squared, will end up being cosecant squared of x minus 1, because a minus b, and then a plus b, which, again, in this case, our a is this, and our b is 1. So we are going to write cosecant of x minus 1 and cosecant of x plus 1. Now, the cool thing is that this is one of those, and that was one of those. So it's a cosecant of x minus 1. There's 2 of them, and there's one of them on the bottom, so one of them will reduce to 1, and then there's only 1 remaining on top. So this is an algebra skill that you should hopefully remember. And if you didn't, well, here you go. So now what we have is, let me rewrite this. We now have this simplified as the cosecant of x minus 1 over the cosecant of x plus 1, which is actually, I think, what we're trying to get to. Yeah, that's exactly what we got to. So that is just your algebra skills to simplify that by reducing those. So you're going to have to write this whole step here in algebra, and then I would cancel those out, which is some more algebra, which is reducing that. So this is my final answer here. So see if you can try this one on your own. Work on the left side and see if you can get to the answer on the right side. So hopefully you tried it. I distributed this out. It simplifies to 1 minus cosine squared, which is just algebra. This turns into just sine squared of x by that Pythagorean identity. Flip it to be 1 over cosecant, which is a reciprocal, and we know that cosecant squared of x is 1 plus cotangent by that Pythagorean identity. Therefore, that would be our answer right here in a simple, very efficient manner.